Okay, so now let's look at neural networks. Okay. So for neural networks, unfortunately, dummy variables are, we have to create the dummy variables ourselves. Okay. Unlike GLM, doesn't do the dummy variable. So if you give factor variables to NNet or neural net, it will just throw an error. So we have to do that. And numerical variables, the normalization that we do is range normalization. Okay. Even though other normalizations could be done, but typically range normalization is what we do for neural net. Like in the case of K and N, we use z-score normalization there. So these are the two things that we have to do. And so we go back to the original data. Okay. Now we want full rank. We cannot use the same dummy variables like we did in K and N, because in K and N we didn't care about full rank. We wanted one dummy variable for each of the K categories. Okay. So we have to create dummy variables new now and use full rank. Okay. And then use that object to create dummy variables. I have here diamond dummy variables.nn for neural network. Okay. So if you now use DM, okay, if you go to that one, for some reason it's not displaying my, so let's do this. Okay, so it has the dummy variables for K-1 categories. Okay. Now we add the dummy variables and then remove the original factor variables, exactly like what we did in K and N. Yeah.
So that will remove that, or that will have all the dummy variables for each of the factor variables that we want. We don't have to do that for, like, that does it for cut, color,
Right.
and
yeah, because
clarity. So we don't have to do it for.
Yeah, because see, in line 307, we are using dm.df fact.vars. So that means we only look at factor variables. Okay. And then it will do a full rank, which means K-1. Okay. And then the line 313 puts those dummy variables into the data frame. So now it has both the dummy variables and the original factor variables. Line 314 takes the factor variables out. Okay. All right, so now we do the partition now and use only the trained data for normalization. Okay, we don't use the whole thing, we use only the trained data. So we partition here and then come up with the range normalization object. So we do pre-process the trained data and method is range. And then we apply that range normalization to both trained and valid. Okay. Okay. Now, when you use range normalization, so you'll see here, so then we can use the neural net library. Okay. All right. So now high margin, there are two possible values for high margin. Okay. Now here we are using two nodes in the hidden layer. We can have more than one hidden layer. So if you just simply use a number, then there's only one hidden layer, and you have two neurons there. But if you use C and a vector of several numbers, then it'll have as many hidden layers as the number of numbers you see in the C, and then the neurons will be those. But of course, don't be trigger happy, because the more hidden layers you have, the more complex the network is going to become, and computationally very burdensome. So, all right, so run that. So it's going to use only one neuron in the output layer, not two. Okay, high margin has 0 or 1, but it will only use 1 here. Okay, so there is only 1. Right? Now, if you want two neurons, one for 0 and one for 1, then we have to create dummy variables for each value of the target. Okay. If you have 3 values like in the homework, then you need 3 dummy variables. Okay, now this one has only 2, so you set up 2, okay, and then use them as the first one plus the second one. Okay, if you have the third one, first one plus the second one plus the third one. Okay. Now, of course, since we have, in class example, we put it right inside the data set, but here, since it's outside the data set, we need to make sure that we remove the high margin out of the trained data. Okay. So now this is going to generate, this is going to train the neural network with 2 output neurons. So here you have. And then, of course, once you have trained it, then you can use it to predict and compute probability. And if you want to use NNet, okay, again, NNet can be used by itself. Okay, neural net can be used by itself. Okay, but when you use it with Caret, you can then control how many samples you want to use, how many parameters you want to use. So when you use it with Caret, that's when neural net will only work for numerical target. It won't work for classification target. So here I have set up the sampling method in NNet control, and then I have a grid. Here and again, NNet, remember, NNet can have only one hidden layer. Neural net method can have several hidden layers, but NNet can have only one. So the size here is how many neurons you're going to try in the hidden layer. So 2:3 means we're going to try only 2 values for the number of neurons in the hidden layer. 2 and then 3. And then decay, dot size and dot decay. Decay is your learning rate. So we're going to try 2 different learning rates. So you have now 2 possible values for hidden layer neurons, 2 possible values for learning rate. So 2 times 2, there are 4 combinations. So this is going to run the NNet method 4 times and select the best. So it takes a while. Neural network is computationally very expensive. All right, so it's done it now, and then you do the prediction. So there you go. And once you have the prediction, then you can run your. You know how to do confusion matrix. You've done it many times now, and same case with ROC chart. Okay. Is that good? You ready for the exam? Well, as I said, okay, don't rely only on the review that I've done. Okay, you need to look at the class notes as well as homework, and I'll continue to be available on Zoom, okay, all through the exams are over. So feel free to drop by anytime, afternoon. So you don't have to email me, okay? So just drop by. If I'm not there, then email me.